In this video, we are going to start solving International Advanced Level Pure Mathematics P1 for January 2021. Let's begin with question number 1. Question is, a curve has equation y is equal to 2x cubed minus 5x squared minus 3 over 2x plus 7, where x should be greater than 0. Find in the simplest form dy over dx. And then before moving to the second part, first let's complete part A. To do this one, what I need to do is, in the simplest form, I have to find first derivative. Let's take the derivative of y, as the variable on the other side is x only. So when I will differentiate, the derivative of y with respect to x would be dy over dx. That is equal to, we already discussed in detail while doing the topic of differentiation, that how we can take the derivative. 2 is constant, it will be as it is. Apply the power rule on x cubed, bring the power down, and 1 minus from the power. If I will subtract 1 from the power, so it will be 3 minus 1. Minus 5 as it is, apply the power rule on this one, bring the power down, 1 minus from the power. Minus, for this one, it will be better if I will write it in this form, 3 into 3 over 2, x to the power negative 1. So it will be easy for me to apply the power rule. So it will become 3 over 2. Apply the power rule, bring the power down, 1 minus from the power. And then 7 is constant, so derivative of constant is 0. So it will become dy over dx will be 6x squared minus 10x. Minus and minus will become plus 3 over 2 x to the power minus 2. And from here it will become dy over dx is equal to 6x squared minus 10x plus 3 over 2. If you remember in the indices, we did that a to the power minus n, we can write it as 1 over a to the power n. To make this power positive, I can write it x to the power 2. Now, for further simplification, we can further take LCM or just leave it in this form. No need to simplify more, because it's only 3 marks question. So it's enough to leave it till this point. Second part is, the point P lies on the curve and has x coordinate 1 over 2. The x coordinate of the curve is 1 over 2. Find an equation of the normal to the curve at P, writing your answer in the form ax plus by plus c, where a and b and c are integers to be found. So x coordinate of the curve is already given, that is x is equal to 1 over 2. So to find the equation of normal, we know the equation of normal is y at any point. The equation of normal is y minus y1 equal to negative 1 over m into x minus x1, where x1, y1 is the points on the curve and m is the gradient of the curve. To take the gradient of the curve, what I will do, I will put this derivative equal to 0. By putting this derivative equal to 0, I will get the instead of putting the derivative equal to 0, what I will do, in the derivative, I will put the point, and then that will give me the gradient at that point. So first, let's find the y point also. The coordinate x is given, I can say this is my x1. So this value of x, if I will put in the given equation, this is the given equation, by putting the value of x in this one, I can get the value of y also, that will be y1. So let's put the value in this one. So I can get y equal to 2 1 over 2 cube minus 5 into 1 over 2 square minus, sorry, just 1 second, minus 3 over 2 into 3 over 2, it is 3 over 2 into 1 over 2 plus 7. So let's simplify it. You can use your calculator directly, it's better. That will save your time. Using the calculator, I can write it 2 into 1 over 2 to the power 3, then minus 5 into 1 over 2 to the power 2 minus 3 over 2. Then within that one I can write, although it's simple, you can use without calculator also, but let's do it with using calculators. I'll write it 1 over 2 close bracket plus 7. So that will give me 3. So it means the value of y is equal to 3. So our points x1, y1, the required points then will be 3, sorry, x is 1 over 2 and y is 3. So that will be 1 over 2, 3. That is our required point. Now this point I will put in the derivative, that will give me gradient. So gradient will be equal to, which is our m. M is going to be dy over dx at this point 1 over 2, 3. So in the derivative, what I will do, in place of x, I will put 1 over 2, because it's the whole equation is, this whole expression is in the form of x only. So that's why I will put only x point in this one. So we'll get 6 into 1 over 2 square minus 10 into 1 over 2 plus 3 over 2 into 1 over 2 square. Let's use calculator again for this calculation. So will become 6 into 1 over 2 minus 10 into 1 over 2 plus is 3 over 2 into 1 over 2 square. So it's 5 over 2. It means the gradient at this point, which is m, is equal to 5 over 2. So now equation of normal, as I have the point x1, y1 also. So gradient, putting the value of m and x1, y1 in this equation, we will get the equation of normal. So that will be y minus y1. Y1 is 3. This is y1 equal to minus 1 over 5 over 2 into x minus x1 is 1 over 2. But as per question, we have to write it in the simplest form, giving the form ax plus by plus c. So I can write it. It will be y minus 3 equal to, this can be minus 2 over 5 into x minus 1 over 2. Shift 5 to the other side. So we'll get y minus 3 equal to minus 2 into x minus 1 over 2. So will become 5y minus 15 equal to minus 2x plus 1, because 2 with minus with 1 over 2 will be 1 only. So shift all terms on one side. So that will become 2x plus 5y minus 15 minus 1 equal to 0. So finally 2x plus 5y minus 16 equal to 0. So we write it, and our unknown variables a, b, c are also now known to us, where a is equal to coefficient of x, b is coefficient of y, and c is the constant term. So I can say a is 2. You can say, even if you don't write, doesn't matter, b is equal to 5 and c is equal to minus 16. So we found equation. That is the end of this question.